Hello, welcome back. I hope you enjoyed that short break because when it comes to programming in the real industry, when you start anything from scratch, initially you need to get the thought process going on your head, on your mind. So, therefore, if you get into the industry, all the coders sometimes, well, everyone code differently. I take a lot of breaks when I do from scratch. So, when I go out for a short walk, I get the idea, come back and do it immediately. So, it's a good practice to get a bit of a break. You don't have to sit in front of your computer and start to code until you finish. So feel free to get out and come back so you can be more productive. Yeah. Okay. So we learned the clock enabling. So now the third step is you got to set the port motor. Port A. So set the GPIOA. Set GPIOA port motor. To do that, you got to copy this, and this is where you are setting this to say going to use as analog function. Sorry, alternate function. What am I talking? Alternate function. Okay. Port motor for uh, alternate function. So as I said, the port motor is where you're using that, and you're going to set bit 5 and bit 4 in port A as 1 0. 1 0 represents alternate function. So simple R, and you're going to enable pin 5 undefined, enable pin 5, basically setting it to 1, and then you need to use pin 4 as well. So just copy that once more, and please be careful with copying because you may make mistakes. To represent in programming, another tip, you can't write 0 directly. You can't say 0 u as 4. So you need to use, instead of R, you're going to use and then you got to negate means it toggles, so it takes the other value. So by writing like this, it knows that this bit 4 has to be 0, not 1, and this is another way of writing. So PGA motor and like that. So you got to write that. If you want, you can check, or I can go further and finish the configure, and then I'll show you. Okay. Why that mode? I'll just put as mode. Okay. I'll show in case if to see this port 2 has been configured, port A pin 2. So terminate and relaunch. This will show, and this will show in the GPIOA port. Bit 5 and bit 4 in port A will change to 1 0. And I'm going to ask you what 1 0 is. See if you can get that in the register. It's loading. 89 switch, yes. Okay, we are in, and I'm going to run as step by step so you can see this port change, because we're using this GPIO enable as port motor. So I'm going step in, see that the clock is enabled, GPIO enable, and then come to APB1, the next step. So now if you see, this bit will change HP1, and we are in GPIO mode. Where will this be GPIO mode? We are in the register RCC. So we got to go to GPIO A, and we're going to change the motor type, which is this motor 2. I'm going to ask you the question 0 cross 2. What is 0 cross 2? If you put your mouse there, and you will see the binary value and the hex value. So that's in decimal. If you leave there, it will show it changes to 02 is 10 in binary. So in decimal it's 02. So that's what it shows. So now you set the that port mode as an alternate function. So now you need to go and specify what alternate function type it's going to. And this is where the control register and the status register for the user, data register and baud rate, this is all will start from here. So the next step is to configure the user module. Configure user module. To do that, you have to start with the alternate function, and you're going to enable those three as you learned from earlier. So we are now doing this bit telling what type we're going to use. So remember, we used 0111 in the alternate function register law. So that has 4 bits. You need to copy 4 times. Control V, yeah. And then you can start with the same way as you see in the register 11, 10, 9, 8, or you can go the other way, 8, 9, 10, 11. It's up to you. It's the good practice is up to you. Either way you can program, but the main part is if you want to negate, you have to negate that bit. If you want to don't negate, just leave it as R. So I'm going by how you see the register. I'll show you how you see the register. So we need what register? APB1 we finished. We need USR2 register. So now alternate function AFRL register we need. Okay, AFRL, it's in GPIO. So if you scroll down, we go into the register, and I'll show you why we're going for AFRL. Okay, it's about to go there, but it's already there. Okay, output register, pull down register, output data register, alternate function. So we are here. So we are writing, we are linking PA2 to USR2 in the alternate function mapping. It's using AF07 alternate function 07, and where the 07 lives, it lives here in 11, 10, 9, 8, 7, being a 32-bit. So if you convert, and if you'll get 0111. So alternate function selection for port for values 0 to 7, you got to go to low, and if it is values 8 to 15, you got to go to the high value. So that's what it means. So to write a 7 in decimal, that's 7, but in binary this is 0111. So that's what you need to write, AF7 as in binary. So this is why we need, I'm going to show the register. I'm going to write it as it is. 11 you need to set as 0, 10 you need to set 1, 9 you need to set 1, 8 you need to set 1. That you will see by this 11 as 0, 10 as 1, 9 as 1, 8 as 1. So this is what I'm writing the alternate function program now for the step. So I'll minimize, go back to IDE. So what did I say? You can't write as 0 directly, so you need to use and you need to negate that. negate, and then tell that bit to be 0. Oh, sorry, 11. Okay, so next is bit 10, and you need to R, just simply R with it, and you got to say 1 U, and that's bit 10. Come on. And likewise, because you're setting as 1, so you can just R and you can just use this. So that's for bit 9, and here 12V, you can set that for bit 8. So now we go on to this step. I will save, terminate and launch to show you this bit in the AFRL change. I'm sorry, I'm going from scratch, so I want to show you and teach you step by step. That's why when I write one register, one address, one line of code, and I'm also proving that in the register, whether you're writing the code and you're actually verifying it in the register to see its output is there or not. So this is a must. So likewise, you will also get the speed as you move further along, but I'm showing you what are all the behind the scenes happen when you write the program after you compile. Okay, we are here, and the AFRL, as you would know, it will be in this register AFRL low. So we are setting bit AFRL 7, bit 11 to 8, so it will show in here AFRL 2. Double check, it will show AFRL 2 0111. Okay, AFRL 2, you will see the changes in here in this register. So I'll just go step into, just show you step by step, and enable, and now peripheral bus. Now it's going to set the motor. Now set the motor. So now it's coming into the alternate function register low. So just pay attention to AFRL 2, see what happens at the end of all this 4 bits. So see, it's already changed to binary value 4. So what is that? Decimal value. So now it has changed to 100, but we haven't finished as it's only a step into. So we need a 7. So now it's 6. Okay, so we did the bit declaration. So as you know, 7 is in decimal, in binary it's 0111, so that's the representation. So this is how we have to write a line of code and then come to the register and check for yourself whether you write it correctly or not. So this shows the whole value. So the AFRL 0 is 0, AFRL is 1, so bit 0, bit 1, AFRL 2, so that's where the 700 comes from, 0 cross 700. Yeah. Okay, so what is the next step? So the 5th step is you need to configure now all the USART registers. So start with status register, configure USART module status register. So this will be, sorry, still we are with GPIO declaring alternate function type. Function type, and now we are setting the module starting with the status register. So this is where this will all be coming in handy. So you need to copy that, copy, come here and paste. So you got to enable this, you got to set this. So we're going here and psat cr1 to write that. I'm just checking whether I covered everything. Just one sec. Okay, configure BR to 900 status register. Insert enable. Okay, we got to write and terminate. So port mode 9, 10, 11. Yeah, written 9, 10, 11, which is good. Then configuring. Okay, the next step, we don't have to register the status register. That will happen inside the function. So we'll directly go to configuring the USART module baud rate register baud rate. So to do that, you need to go here, copy this baud rate, register, and you're going to do that calculation, and you can write remember the calculation that I listed here. This is a baud rate calculation. So you need to load this 0 cross 0683 directly into the program. So all you got to do is 0 cross 0683, and this will put the value, baud rate value, into this register. Okay, so the next step, I'm just going step by step, so in case if I miss, then I will let you know what I'm up to. Okay, then the next step is we need to enable the control register, because we need to verify the data transmission happened or not. So the sixth step would be configure USART control register. To do that, you got to go and copy in this. Let's see, Control V, and we are basically setting this to we're going to write today, so we're going to transmit, so we have to write the data. So for that, you got to R with this value 0 cross 008, sorry, being a 30-bit register, so that's what you got to write as a 32-bit. This is CR1 to have set the USART UART enable, and then you need to set this one. I'm just checking. Okay, baud rate. And then you're going to use, first we need to tell the data transmission, then you need to copy this and enable the transmit enable, which I will show you shortly. So for that, you need to enable this address. Okay, just save. So we need to go to USART2 to show you the transmit enable. We are in reference manual. I'll go to USART register by going to contents. Come on, contents, show us. Yes. You're going to go to USART2. So it's DMA, GPIO, RTC, I2C, USART2. Yeah. Then you need to go to USART registers. So you're here, USART register, and you're using control register 1. So that's the USART register, control register 1. You need to enable this bit, transmit enable, to start the data. So that's why you set this bit as 1 and then all the 3 bits as 0. So that's why you need to write this. So what is 1000 in binary? Sorry, that is in binary, but what is it in a 32-bit? If you convert that to decimal, that will come as 8. So that's why you're setting the first bit of the 32-bit first as 8. to enable just this bit. See if I can explain with the point. I'm just trying to explain how that 0008 happens. So I'm just opening a point. I'm just drawing. Just give me some sec. I'm just drawing a register. So imagine that's a 32-bit register. So it'll take a long time. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not a good example, but I will show how the representation is. So I need to write 1 there, 000. I can't write. Sorry, pencil. So I need to write 1 here and 000 here. That's a 0. That's a 0. And this is a 0. This is bit 0 of the 32 bits. That's the first bit. And this is the second bit. And this is the third bit. So you know 32 bits, 32 bits, 32 bits will be like this in the register mode. It will be first 0, it will represent bit 29, 30, sorry, 28, 29, 30, 31 because it's 0 to 31. And the next will be that 8, and the following will be that 8. And this is just a bit representation. So the first 0 will represent this 0 to 8, 0 to 7, then 8 to 15, 16 to the rest, so forth. So you have to write 8 here. So that's why I'm writing bit 3, 1. So this will become 8. So out of the 32 bits, that's how we have to write. Hope you are clear with that. Okay. And then you setting CR1 as 2, 1 cross 2 000. So these are all reserved. So we are not worried about all this. So we need to transmit this as 2 000. So this is all 0, 0, 0. You need to write a 2 here, which is bit 13, bit 7. That's TXEIE, bit 7, bit 2. So this is what you write as 0008. And then to enable the, this is to enable the use art enable. So what this is, if you go to the USART register, we are in GPIO register. So if you go here and if you go to control register 1, and we need to enable this bit 3:1. So I'll go save and I can terminate and relaunch just to show this so far what we have written. We are not far off, so we are nearly there, and you can see and verify your USART communication in Arduino. You got to download Arduino. I deleted. I will show you the download of Arduino IDE as well. Okay, it's still debugging, still debugging. Yeah, still converting from C perspective to debug mode. I want to just show you that USART enable. Yeah, switch, and we are in USART2 CR1. We need the T1, this bit. So I'll go step into. Once it comes there, then you will see. Until then you won't. So it's gone to peripheral mode enable clock. Now it's setting the GPIO motor 10, letting to say its alternate function has been enabled. Now he's choosing the alternate function register, AFRL, and step into. Now it's going into this step. It will execute that. Now the baud rate register will have this value. So if we go here after this, the baud rate, step into, see, you have written that baud rate value directly into that Mantissa. You might have known and you studied all of this Mantissa and fraction, so that's why we calculate this 683. Okay, we're worrying about this control register 1. So I'm going to hit another step into. See, it changed. So we just enabled the USART, and the value of that USART, to enable that, if you put your mouse there, and that's decimal 8, so that's what we written, 00008. And then another step into, and 2008 for. So you need to enable this USART enable. So see, this is enable, and this also enable. So that's the meaning when you write control register. So you writing two different of the 32 bits. You have to enable first the transmitter enable, and also to send the data, and you also have to enable the USART. So these two bits have to be represented in decimal value to binary value. So that's what it's shown there. So that's to enable transmitter enable, or set, I should say, set. And this is set for USART enable of the 32 bits. I'll just write here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So if you convert this, then you will see this value. So that's what happened there. And for here, you're going to enable that. So to enable 2, you got to enable, I'm trying to do the math in my mind, just give me a sec to represent that into 32-bit, so you will understand. So 13 of 1 UE binary is 1000 followed by all zeros and 10. Okay, 10 is 0, 1 2 3 4. UART enable UE. Let's go to the register. I know I'm a little bit confusing you, so I'm just going to the register. You need to enable, that's a baud rate control register. You got to enable this 13th bit as enable as well. So to do that, we have written 1000, so that's 8. 1 2 3 4 5 6 7 8 9 10. So the 10th pin, you need to enable that as 1. So what do you get? Because it's all represented with 4 bytes, so that's 8 0 to here, 0 0 0 0 up to here, then it's 0 1. So what is 1 0? It's 2. So that's what it is. That's what it is. 0 1. So because that's the 10th bit and the rest are all sorry, that's the 13th bit is 0 12 11 10 9 8 7 6 5. Fourth bit is 1 there. So in order to use this in that register, I will go, yeah, because it's all reserved. That's okay. It's all reserved, so all will be 0. Only the fourth bit, only the third bit will be 1. The rest are all 0 for enabling this. For enabling UE1, this bit will be 0 and anything before this will all be 0. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 zeros will be there in the front. Okay, so now we enable both. Okay, now we need to do a write function so that we can communicate and do the data transfer. Okay, now we're writing the write function, so we need to declare the function first. Function declaration void, we are writing for user underscore write of void. Okay, you got to call this, but we are not using this function, but you got to call it here, right? It's there, and you're going to write that function void user underscore. This is for writing and checking the value using a printf statement. So to write that, you need to send a character. Sorry, it's not void, so you are sending a character actually, so it has to be int character. So you're sending a character in the argument, and if you recall in the system call, if you want to say, I'm going to give this example day 2. If you recall in system call, we used a printf statement. To do that, you copied this to see in the console window, so you need that, but we are now writing just a direct input to check on the serial terminal. So to do that, you are writing this int write function, and you are just writing directly, you're putting a character, put character. So that's what you are doing it here in this main C. Input put character, put char of, what is it, int character, and then you're returning that character value. Okay, so this is you are right. Okay, sorry, that's not the UART right. That's for the printf, which I will show, but before that we are writing the uart_write function. So the uart_write will have to satisfy and check the data transmission. This is where we need the status register and the data register to get in to do its job. So to do that, int useInt character, we're going to use this in other part of the program, so I will still keep it. So useInt is, I'm going to just write a simple while not equal to checking with first the status register to see whether the data is ready to be received. Status register, and then you need to AND with this value to get your first data. Okay, this is basically saying we have to write the data and save it in the buffer and wait for it until it gets empty, and then you get the data out and show that in the you are enabling the TXE, the data transmit enable by going here. What that means is useart, you are in status register, you got to enable this register TXIE, ideally CTS TXE. So this bit you got to enable bit 7. Bit 7 is transmit data register empty. So you need to say that the data is ready to be transmitted, so you need to enable that. So this bit is set by the hardware itself, so the TDR register acts that, and if you send a 1, that means the data is transferred to the shift register. If you send 0, that means the data is not transferred. So you have to enable that first by writing this, and this 0080 is to enable that bit 7 TXE enable. So that's what, if you calculate, that will come as that. And now you got to wait until the buffer gets empty, and then you're going to read the data back. So to do that, you got to, where are you going to load? You're going to load the data register. So this is where you're seeing the data. Control C, and your value will be, you're setting this as the enable, so character ending with high value, 0 cross FF. So this is to wait until the buffer gets empty, and then you're retrieving the data, the character as 1, and loading that into your data register. So this is just a simple write instruction, and this is how it works in. So just save, and I'm going to write the printf statement now. So just to print and see, I can just declare a straight function as input character like that, and I'm going to call whatever you're going to write, the useart underscore write of what you're writing, the character, and then you return that character. So this is a simple function. And this is to see the output in the peripheral, so you need to include, and to see it in the function, so you need to go into your main function to see the printf statement. So you got to write it here, you have to check this in the output. So I'm just writing while of 1, I'm printing the statement, so printf hello world from A to Digi learners okay, learners, yeah, and backslash r backslash n, and I'm ending this. Okay, so all the program now done. I'm just looking at other things to see if I missed anything. So now we can see the output in the serial terminal, which is what we want. I'm just checking if I missed anything. You are right, and then int main. Can be user, right? It doesn't matter where you put the function. It can be before or it can be at the end, but just to be make more uniform, I will keep this before the main program. So Control X, I'll keep it here. Right, function here written, that's the main. Okay, learners, yeah, I'm happy with that. Save, going to build the project, minimize this. And doing a right click, okay, terminate and relaunch, because it's already in the debug mode. So while that is doing, I'm going to go here and download Arduino IDE so we can check the output. So just go into Google, we're going to download Arduino IDE, download. If you click that, so click the Arduino download and install. This will take a while. I can give you a short break, so once this is done, then we can check the output. So please go and enjoy that break. I will see you back shortly. So do this on the installation as well. Go to Google and type in download and install Arduino IDE, and then go in and click on the download. There will be a download option. Still it's loading. If you don't need Chromebook, download Mac, Windows, download the latest release. Click on the download the latest release, that will turn down. So this will take a while, so that's why. Okay, it's going fast. Okay, I'll show you this as well. It's not far off, you'll see the result. I'm just as keen as you are to see the result. We did all the hard work, we learned how to write, and now it's the time to see the reward of your program, to see that output. So we're going to see that output shortly, so just bear with me. Not long to go. Okay, then double click on the Arduino IDE, the downloaded files. It will check for spam or anything like that. So it's checking my antivirus thing and it's saying it's okay, so it's going to open soon. Just give me a sec. It's opening Arduino IDE. I'll just minimize this. Also switch that to perspective mode. Where are you? I downloaded, I don't know where. It's still loading, sorry. Okay, it's loading on the background, which I will show now. So that's the program. So we went and downloaded Arduino IDE by going to Google and typing Arduino IDE. This is what you get. And we are setting up Arduino IDE. I agree. It's only for me, so click next. And then by default it goes and sits in programs under Arduino IDE. Just click install. This will install the IDE. This will take a while. I think it has to check all the background check and all the necessary files, and when it's downloaded, it will download the option in the desktop. You got to double click that, like the STM32 cube IDE. This is also another IDE. You need to double click this, And this is where you can see the serial terminal, serial communication. So from one ID to the other ID, you're going to see it. In the meantime, I'll see why this red error is red yellow line. Hello world. Okay, because it's in a string. Okay, it's showing warning. Okay, nothing to worry. Nothing to worry. All good. Character. Yeah. Good. So still loading, I guess. Yeah. Nearly there. Nearly there. Sorry to keep you waiting. Or how about this? I'll wait for this download. I'll give you a short break. I'll see in a couple of minutes. Go and enjoy that break, and we'll see the output soon in Arduino. Catch you later shortly.